Let's look at a few more examples. Number 5, find the volume of the solid formed by revolving the region in the first quadrant, bounded by the curves y equals 4x, y equals x cubed, and about the line y equals -2. Notice the adjustment on the x-axis. This is 1 unit, whereas counting up 4 blocks is 8 units. That's just going to help to maximize our viewing window. So if I start with y equals 4x, the y-intercept is at 0, and then the slope is 4. So up 4 over 1 takes us to here. Up 4 over 1 takes us to here. So I can graph more, but this really will be the only part of my line that I'm going to need. Okay. Y equals x cubed. So y equals x cubed, starting at 0, 0. 1 cubed is 1. 2 cubed is 8. So we get this. Again, I could graph more, but they only asked for the region in the first quadrant. Now we shade that region so there is no confusion about what it is exactly that we are rotating. And now we see the line to rotate is y equals -2. So if this is counting my 2, 4, 6, 8, down here is y equals -2. So let's graph that horizontal line, y equals -2, and show that we will be revolving around that line. Let's do a reflection over that line. So down 1 unit, 1, 2, 3 units above the line, 1, 2, 3 units below, 5 above, 1, 2, 3, 4, 5 below. So we've got that, and we've got that. Again, I'm just doing a light reflection. Now I ask myself how to slice it. I know I'm revolving this way, and I always slice perpendicular to the axis of rotation, up and down. So that's going to create this circular slice. But notice that there's a gap in between where the axis of rotation is and where the shaded region is. So I have another circle to think about, which means I have a washer. And if I have a washer, I need a big R and I need a little r. And if my slice is going up and down, I am doing top minus bottom, such that I draw my radii from the axis of rotation for big R all the way out to the farthest away part of the original curve, the original shaded region, and for my little r from the axis of rotation all the way to the closer part of the shaded region. And if I'm doing top minus bottom, the top for big R is the linear function 4x minus the bottom is here's big R top, big R bottom, the axis of rotation. So minus the axis of rotation, y equals, this is what y equals -2. Perhaps we label it right here so that we don't have to keep looking back at the directions. So minus -2 from the axis of rotation. Little r, the top of it, where did I label it? Right here at the cubic function, so y equals x cubed minus, and again the bottom of it, the axis of rotation, y equals -2. We can simplify this a little bit, which would be helpful. So this will say is 4x plus 2, and this will say is x cubed plus 2. One way to think about why it's plus 2 is because we shifted the axis of rotation down a unit farther away from the shaded region. We have to add that unit that's farther away. So the 2 units of space that was added. Now let's recall that volume is the integral of the area of the slice. And if we know that our slice is a washer, then we're going to be saying pi integral r squared minus r squared, and we know we're doing top minus bottom, so that's with respect to x. So we've got pi, big R is 4x plus 2, little r, x cubed plus 2, Don't forget dx to close out the integral. Now we just have to say from where to where. So we look, the x that starts our region is at 0. The x that ends our region, now be careful here because we counted each 4 blocks is 1 unit. So 4 more blocks, 2 units. So 0 to 2. And there we have our integral. Go ahead and use a calculator, evaluate it by hand. Either way, 848 over 21 pi. Would you like to try the next one? Pausing the video, come back and see how you did. Let's start by sketching the region. Notice same functions that we started with before. So 0, 0, 1, 4, and 2, 8. Linear. Y equals x cubed. Make that one green again. 0, 0, 1, 1, 2, 8. So again, we have that region that we can shade between those two curves. This time, what's different? We're going around the line y equals 10. So let's find 8, 10. 10 is right up here. So now when we show our reflection, it's going to be reflected to above the line. So 1 unit above, 3, 3, 5, 5. And again, I'm just doing a light sketch so that I can visualize this three-dimensional object. So now we say, again, slice perpendicular to the axis of rotation. I'm going to have a circular slice. Let's make that orange like the other ones. There we go. And because there's a big gap between the axis of rotation and the shaded region, I'm going to have an inner circle. So again, we have a washer. And again, we're going top minus bottom since our slice went up and down. So washer means I have a big R and a little r. Always draw the radii. In this one, it's really important because it's different from what we did in the other ones. Start at the axis of rotation and go to the original curve. The farthest away part you have to go to the farthest curve is big R. From our axis of rotation to the closer curve, that's the little r. That's the radius for the gap. For big R, top minus bottom. Well, what's the top this time? This was the line y equals 10. So the top of the big radius is 10 minus the bottom of the big radius is the cubic function this time. Little radius, the top is y equals 10. And this time the bottom, the closer curve, is the line 4x. Now we can simplify those a little bit to be 10 minus x cubed and 10 minus 4x. We remind ourselves what is volume? The integral of the area of a slice. And because our slice is a washer, pi integral big R squared minus little r squared, because it's top minus bottom with respect to x. Plug in what we have. Big R, 10 minus x cubed, square it, minus 10 minus 4x, square it, dx. Look at where our region starts, x coordinate 0 to x coordinate 2, just like the last one. Evaluate the integral. The hard part is the setting it up. Evaluating the integral is the easy part. Let's look at one where we set up the same picture, but now we're going around a vertical line, x equals 2. Let's see how that changes things. So I'm going to graph this same picture again. I'll even use the same color coding. 0, 0, 1, 1, 2, 4. Beautiful little sliver of a region there. Shade that guy in. And now let's figure out where is our axis of rotation. X equals 2. Well, remember we counted 1 and 2 will be right here. So vertical line, x equals 2. Now we're going this way. Always start by graphing the reflection. 1, 2, 3, 4 to the left, so 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left, so 4 to the right. And 8 to the left, so 8 to the right. And really this sketch just helps us to get an idea of what this solid is going to look like, if it has a hole requiring us to use a washer, or not a hole requiring us to use a disc, and which way to slice. Although, if we know the axis of rotation is vertical, we know we have to slice horizontal, always perpendicular to the axis of rotation. So I slice, and I have this circular slice. But I have space, so I have to make a circle for that space, which means I have a washer again. But this time, because my washer is going right and left, I do right minus left when I find big R and little r. It helps if you draw big R and little r. So I'm going to put my pencil on the axis of rotation first. Then I'm going to go all the way to the original shaded region. Notice that's requiring me to go to the left. There's big R. Little r from the axis of rotation, but to the closer part of the shaded region. So that's to the green curve right there. That's little r. So on the right side of big R, that's this red line, the vertical line, x equals 2, minus. On the left side of big R, go, 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 go until we get to the farthest away part, that's this y equals 4x curve. Well, if that's y equals, remember that right minus left, that's in the x direction, which means I want it to be x equals something. X equals not y equals. So x equals, if I solve that equation, will be y over 4. Therefore, we're reminded that right minus left means I am in terms of y. Let's look at little r. Little r starts on the right side, again at x equals 2. The left side is the green curve, y equals x cubed. But I have to solve for x. So x equals y to the 1/3. So y to the 1/3 into my little r. Of course, we don't really need the parentheses. It's still going to work without them. I feel like I can do better writing y divided by 4. I don't want to be sloppy and then not be able to read my work later. I remind myself, what is volume? Integral of the area of a slice. I remember my slice is a washer. When I see that my slice is a washer, I say pi integral big R squared minus little r squared. I already wrote what big R and little r are, so I have to plug in to my integral now. Don't forget to square it, big R squared minus little r, 2 minus y to the 1/3 squared, and then dy. Now, if I'm using y's, remember we use the limits of y's. So the lowest part of our region is at the y coordinate 0. The highest part of our region is at the y coordinate 8. So 0 to 8. Again, whether you're solving this by hand or with a calculator, we're going to get 112 over 15 pi. Isn't this fun? You could do some more.